Okay, let me go to Smart PLS. We start with the most fundamental one, which is the first technique. Okay, I write down in the chat box so that you're clear. The first technique today I'm going to show you all is regarding repeated indicator approach. Okay, I write down in the chat so that you know. So I'm going to show you all how to perform the repeated indicator approach. Okay, so quick one. I will share my screen, Smart PLS. Okay, assuming you have this model right now, okay, assuming you have this model right now, and this model will have competence, likability, satisfaction, and loyalty, and this is by the Smart PLS dataset, their team itself, so I use the same. So it will be convenient for me to facilitate. Okay, assuming there are literature saying that competence and likability are dimensions that form the corporate reputation construct or concept. So in such a case, I'm going to draw the model right now. Okay, now we will perform this technique called repeated indicator approach. Hey, sorry. Okay, let me rename this thing called CR first. Okay, so we know that competence and likability are dimensions that form corporate reputation. I'm not showing how you ought to do reflective. I'm not showing this one. Rather, I'm showing reflective formative because it makes sense in literature why people form reflective formative. So in such a case, corporate reputation will be your exogenous variable or independent variables. So CR will point to satisfaction and CR will point to loyalty. So in such a case, we know that, oh, satisfaction will be your mediator and loyalty will be your endogenous variable and CR is your IV right now. And competence and likability, they form CR. And this is what we call a second order reflective formative. But when you want to run analysis, you cannot run with just everything is blue, but just one construct, which is from your second order construct, you have red color. And this is what we call phantom variable, or variables that do not have item. Therefore, to perform this analysis, we will do this repeated indicator approach. Okay, what do you mean repeated? The item here, COM1, COM2, COM3, like 1, like 2, like 3, the item I highlighted again and will be repeated in your second order construct. Will be repeated in your second order construct. So in such a case, you can see that your second order construct also will have the items like your dimension. And this is what we call repeated indicator approach. So because you repeated the thing, you do not need to see whether the item, researcher do not need to see whether your second order got what item. Therefore, you can actually hide the construct. Okay, you can actually hide the construct. Okay, so therefore, now no longer red color for your CR. In such a case, you can run your analysis. But when you run your analysis in repeated indicator approach, first thing you need to make sure is always run the PLS algorithm and check for the assessment like reliability. Okay, check for the assessment like your reliability, your discriminant validity, and so on. Okay, you need to check the basic one. Okay, because this technique is called repeated indicator approach. Assuming, I use the word assuming here, assuming COM1 itself have very terrible and bad loading, assuming it is not 0.802, assuming it is like 0.102, low loading. So when you low loading and you do cleaning that time, you need to delete this one because the item and the approaches that you use is actually called repeated. So your item also need to delete COM1 inside of the CR. So this is what we call repeated. What you have cleaned in your outside, you need to clean inside also. So lower order, you clean your data because of low loading, then you clean your data inside, also low loading, and then you delete it, and then you can proceed with your analysis. So this is assuming if your loading is poor. Okay. So in such a case, let me go back to normal. In such a case, if your cleaning is perfect, there's no issue in terms of reliability, validity, then you can simply just run your bootstrapping and PLS algorithm. You just run and you hit your button and you will get your result in a second. And here you go. And this is what we call repeated indicator approach, which is the first step. But what I want to highlight to you that in this repeated indicator approach, there's always a certain weakness. Okay, if you pay attention here, if your second order construct, again, I'm going to highlight this thing, which I mentioned just now in the slide. If your second order construct and you do a reflective formative type 2, and your second order construct is an endogenous variable, you cannot use repeated indicator approach. You need to move to two-stage approach or extended repeated indicator approach. Okay, if it's this second order construct is part of endogenous, not IV. Right now I'm showing you IV. I'm going to show you the example just now later on. And the second issue that you need to take note is if in the very beginning, your competence have 3 items for your dimension 1, and your likability is your dimension 2 have 2 items. In such a case, you do not have balanced number of items. When you do not have balanced number of items of each dimension, please don't use repeated indicator approach. You will have, in terms of biased result, to produce the best value of CR than to predict on satisfaction as well as loyalty. So this is the 2 issues that I can roughly tell you that first, if you do a type 2 reflective formative model, when it is endogenous, not exogenous, endo mean at either mediator or dependent, you cannot do repeated indicator approach. You must do a 2-stage approach, which I'm going to explain later. And if the number of items in your dimension are different, then stay away from repeated indicator approach. You can focus on 2-stage approach or maybe extended repeated indicator approach. There's one more technique called extended, but now I'm showing you the basic repeated indicator approach. So I hope you're clear with this. Okay. So stop here. Any question on repeated indicator approach? Any question? Any question? Any question? If no question, I move to the second approach because I'm going to show you all 4 approach. Okay, clear. So the second approach that I'm going to show you all today, I'm going to type in the chat, is the embedded 2-stage approach, which I'm going to type in the chat. Embedded 2-stage approach. Some people also call it as joint 2-stage approach. But the more scientific term is called embedded 2-stage approach. I'm going to show you all step 2. Okay. Okay. But now I'm going to change a bit different. Okay. I'm going to change a bit different so that you have more, different variation of seeing how 2-stage can perform. Let me change a bit some variation of the data. Okay. Now, let me use a variable called quality. Okay, quality. You remember just now I mentioned that if you plan to do a type 2 reflective formative construct, you have an issue. You cannot do a repeated indicator approach. Okay. Now I'm going to tell you what is the issue. Which this one also I explained in the slide earlier. The issue is something like this. Okay, we are doing repeated indicator approach. I show you the item so that you all can see. Okay, let me go. No, I think I'll go bottom. Okay, I repeat my item. Okay, as you can see, CR is repeated item from the dimension. Okay, so I have shown you the item. If I plan to use CR as my endogenous variable, part of the endogenous or mediator variable. So if I run a PLS algorithm, my R square is equals to 1. And if I run a bootstrapping,
Jacky, are you sharing any slide?
oh, I never share. Yeah. Sorry. Okay, I'm sharing right now. I forget to share.
No worries.
Okay, can you see here right now? Guys, can you see?
Oh, good. Oh, good.
Okay. Okay, now change a bit. The scenario. The scenario now change into a way where, yeah. Give me a sec. Okay, give me a second. Okay, back to normal. Let me back to normal. Let me delete this one. Then okay. Okay, now let us change to a scenario where just now I mentioned one thing. If you plan to do a reflective formative second order construct, and this reflective formative second order construct is in your endogenous, such as this one right now, where quality point to CR, CR will be your endogenous. Or it could be a mediator right now, okay? If you have such situation, you are doing reflective formative type 2, and you run your analysis using this technique called repeater indicator approach, you will see your result tends to produce weird result where your R square, as you can see, R square here equals to 1. So there's no such thing where R square equals to 1. On top of that, if you run a bootstrapping, your result also will get weird result. Okay, now you can see your result also will get somehow quite weird result, okay? Okay, you can see the value is quite high, but when you look into the path coefficient, let me change to path coefficient of the t-value, 0.006, very weird result, right? You can see the path here, 0.006, very weird result, okay? Although t-value is significant, but you get a weird result of 0.006. And this is the issue in performing repeater indicator approach when you do it in a type 2 reflective formative construct as an endogenous construct. So you have a problem. In such a case, I'm going to show you how to perform the embedded two-stage approach. Okay, the embedded two-stage approach looks like this. Okay, assuming you run your PLS algorithm, okay, you get R square equals to 1. So as you can see, R square equals to 1. So from this analysis, first of all, of course, you do the traditional way of doing things, that you do cleaning. Okay, when you clean everything, okay, when you clean everything, and now you cannot straight away interpret based on the results. You need to do from the repeater indicator approach, you need to move on to the second step. And the second step is called two-stage approach, which means right now you are from repeater indicator approach, move to the second step called two-stage approach. Therefore, you need to click on the latent variable. Okay, when you run your PLS algorithm, you get on your latent variable. From your latent variable, you click Excel format because you want to save the score here. And this score itself will help you form the second order construct of your corporate reputation. Okay, so I stop share here. I'm going to open my Excel sheet. And as you can see in my Excel sheet, okay, now in my Excel sheet, I have saved my score of the latent variable score just now in Smart PLS. I'm going to paste my result on my data set and delete what I'm supposed to delete. I need to make sure everything is clean. Okay, from here itself, I need to make sure everything is clear. Okay, so from here itself, I save the score from the PLS algorithm, from the original result from repeater indicator approach. I'm going to save this as a new data set called CR common CSV. Then I call this as CR with latent variable score. I save it in my desktop as my new data set. Okay, I'm going to stop share here. So right now I have saved in a new data set. From there itself, I go back to my Smart PLS software. And in the Smart PLS software, import my new data set. And my new data set is called CRV LVS. Import. There's some problem with my data. Give me stop share a bit for a while. I need to clean some data because I save very fast. Give me a second. Give me a second. I need to clean my Excel sheet. Competence. Okay. I save. Give me a second because I do a quick save just now. I need to clean some data set. Clean content, and I go up and clean again content. Okay, let me resave. Desktop save. Okay, I go back to my Smart PLS software. Import data file. Desktop. It works right now. Sorry, just now I saved wrongly. I do a very quick one. Okay, so right now I have import. I hope you can see my screen, Smart PLS. I have import my new data set, which is CR with latent variable score. one, I have import this data set. So right now, what I need to do for the embedded two-stage approach is like, as we know earlier, that what I'm going to show you earlier was this repeater indicator approach. What we want now is like, we need to clear all the, you need to clear all this thing, which is this thing have to be clear. This item here must all delete. From here, we need to insert the new variables that you have saved as latent variable score, competence and likability to CR. From here itself, because it is reflective formative type 2, we need to change the arrow. When we change the arrow, it will be in this format where this is what we call right now reflective formative. And right now, this is called the embedded two-stage approach. Where when we say embedded, it is from repeater indicator approach earlier. From the repeater indicator approach earlier, you save the latent variable score. And when you save the latent variable score, your latent variable score of competence likability as the dimension will now become like your item. When it now becomes an item, it will then form to CR. And this is what we call embedded two-stage approach, where now you can simply just run your analysis, you will get your appropriate result, where just now here is 0.006, and right now you get the correct answer 0.795. And this is the result of doing the embedded two-stage approach. So I hope you're all clear with the result. So any question with the embedded two-stage approach? Any question? Any question? Embedded two-stage approach?
Good, I guess.
The problem for Jean, the problem for limitation of second approach is based on my experience when I published a paper with my co-authors in Journal of Quality and Quantity. We found that two-stage approach tends to produce lower value in terms of in-sample prediction, which is your R-square. The R-square will become weaker compared to the repeater indicator approach. So this is one weakness of, I'm not saying weakness, I also not say limitation, because the nature of two-stage approach, you save the score, you will have somehow less information. You have somehow less information. So therefore, your in-sample prediction, which is the R-square, is weaker a bit, slightly a bit. So that is my answer to Jim. Yeah. Okay. Now a quick one, which is the this will be, I think I'll cover this one. Will be the last one. Okay, wait for a while, let me cover the last one. Now will be the last one called disjoint two-stage approach. Okay, I type here at the chat, you can see the last one. I think I covered these three enough for me because we have another session. So disjoint two-stage approach, we're going to show you right now. So in disjoint two-stage approach, it's a bit different from the embedded two-stage approach. The disjoint two-stage approach is in the beginning, you do not have any dimension level. You just have the item of competence and you have the item of likability. Okay, you have these two dimension. Okay, you have these two dimension. This is com, this is light. Okay, you have these two dimension. Okay, so you have these two dimension. In these two dimension, you do not have second order yet. What you need to do is very easy. Your IV all point to your dimension and your dimension point to your endogenous variable. In such a case, you need to run your PLS algorithm. And you run your PLS algorithm, same thing, you just need to save your latent variable score. Okay, when you save the latent variable score, the same process where you save the score, you save the score to your Excel, and then you bring in or import in the new data set. So when you import into a new data set, you will produce the same stuff again, where once you have done this one, you could duplicate your model again. When you save your data, you duplicate your model again. And then from this data set, you then now delete your dimension, and then you bring in the same stuff again, competence, likability, as your second order construct. And then you just need to point in such a way. And again, this is what we call the disjoint two-stage approach. which means you are from lower order construct, and from your lower order construct, you point all the arrows towards your IV point to your lower order construct, and your lower order construct point to your endogenous variable construct, and then you save the latent variable score after you clean your data. Then that will be the new data set, which is new latent variable score, and this new latent variable score will use as the disjoint two-stage approach. Okay, so this is what we call the disjoint two-stage approach. I hope you are clear with this. So I hope you guys understand on these three technique. There are more technique. I think I hit the time already. Correct, no, Hiram?
Yep.
Yeah. So of course, in the very beginning, I'll teach you the extended, but since we do not have time, so there's no extended. Unless we have 5 minutes, then I cover extended.
Yeah, go ahead.
Oh, okay. Then now I'm showing the last one, extended. Extended repeated indicator approach. Okay, now I cover the last one, extended repeated. I found that extended repeated indicator approach tends to produce better result from the two-stage approach, and also better result than the traditional repeated indicator approach. But this is my perception because from my experience when I run analysis. So I'm going to show you extended repeated indicator approach. Okay. If you ask me, Jacky, whether to use extended repeated indicator approach, my answer to you is yes, you should use it. But the difficulty to use it is a bit quite confusing. Now let me show you how to do this extended repeated indicator approach. Okay, yeah, back to this fundamental. Let me delete the item first. Delete the arrows. Sorry, let me delete the arrows so that you can see clearly. I will delete satisfaction this time so that it will not confuse you. And right now, I'm going to use back the same thing. This will be CR. And I'm gonna hide this thing. No, I'm gonna hide this thing. Okay. So right now, I'm gonna show you the repeated indicator approach, but not the old one, but this is what we call extended repeated indicator approach. Okay. So the extended repeated indicator approach is similar with repeated indicator approach, but it extends from the traditional repeated indicator approach. What does it mean? Because when I run a PLS algorithm, my result tends to be weird, right? My result will tends to be weird, where you see this relationship path and this relationship path tends to be 0.000, but R squared equals to 1, tends to be weird. To extend this repeated indicator approach, your quality need to point to the dimension. In such a case, this is what we call extended repeated indicator approach. You use repeated indicator approach, but you extend it by your exogenous construct. The arrow must point to your dimension. From here, when you run your analysis, you get your results, right? But still, the result tends to be weird. But to read this result, you don't read this negative 0.4, but as you look at your combo box at your right-hand side. Okay, look at the combo box on your right-hand side. Your path coefficient right now must change to total effect. So this will be your true value of path coefficient called 0.94. You just need to take this value called 0.94. Why we need to look into total effect rather than path coefficient? Because your quality point to competence and your competence point to CR. Therefore, they control the effect of this competence and likability. Control the effects of competence and likability. When they control the effect of competence and likability, you're going to have a true value result of path coefficient from quality to CR. And this is what we call the extended repeated indicator approach, where your only this value, which is 0.94, if you choose path coefficient, you still get the wrong result. Sorry, you still get the wrong result. What you need to do is change to total effect. And this total effect is 0.794. You're going to use this value. And this value will be your true value of your path coefficient when you do this extended repeated indicator approach. So this is the step 4 that I'm going to teach you. Yeah. So I hope you're clear.
Okay, I think we should take a 10 minutes break. And all of you, we will see you at 3:40. Okay. feel free to ask. I mean, feel free to write the questions, and Jacky can address in the last session.
Okay.
All right. So
Yeah.
I'll see you all in 10 minutes time.
Yeah.